Hi guys, today again we are continuing to talk about our variety of exponent rules, and we're going to introduce a brand new rule today called the quotient rule. And just like we talked about in the last video, anytime you see this word quotient in there, that means that there's going to be something related to division or a fraction. And let's go ahead and jump into our first example to talk about where that comes in. So in our first example, we have y to the sixth over y to the second power. Now, as we're getting comfortable with this quotient rule, I do want us to go back to basics, and please go ahead and write out y to the sixth over y to the second without exponents. So I'm going to write out y to the sixth as y times y times y times y times y times y. All of that over y times y. Now, thinking back to just regular old division, and when we're able to cross out common multiples between the numerator and denominator, there are 6 of the y's up top and 2 of the y's down below. Now, quick side quest, if we think about 2 over 2, think about this fraction. We know that 2 over 2 is equal to 1 whole. We're going to apply this same principle, this same concept over here when we are talking about our exponents and using our quotient rule. So I know that y over y, we are creating 1 whole right there. We can just cross that out. Now I'm going to erase my side quest. And I'm going to do this exact same thing with another 1 whole of y times y. So I am left with nothing in my denominator, but I still have 1, 2, 3, 4 y's left over in my numerator. Therefore, my answer, or my quotient of y to the sixth over y to the second, is y to the fourth power. Now, some of you guys might notice that 4 is the result of 6 minus 2. So if you take the numerator's exponent minus the denominator's exponent when we have the same base, that is what your resulting exponent will be. I'm going to go ahead and erase this, and we're going to create a rule to write out for our quotient rule. So whenever we have y to the nth power, actually, I'm going to go ahead and use the letter a because that's what we are most comfortable with. A to the nth power over same base, a to the nth power. We know that our result is going to be a to the m minus nth power. Let's do one more example to showcase how this works in a slightly different example, okay? So in this next one, we have x to the third over x to the fifth power. Now, using our quotient rule here, we know that we're going to take this numerator exponent and subtract the denominator exponent. So 3 minus 5 is going to equal -2. That's using our quotient rule. But let's go ahead and write this out, and we'll talk about how this looks in proper formatting. I wrote out x to the third in its expanded form without exponents. And in the denominator, we're going to have 5 x's written out. And we're going to use that same principle. We're going to cross out those 1 wholes from both the numerator and the denominator. We're left with 1, 2, and then we cross out 3 wholes. Now, we're left with nothing in front of anything in the numerator. We have nothing left over, but remember, always referring back to those invisible things that we don't necessarily talk about. There's always that 1, that invisible coefficient of 1 sitting up top in the numerator. And then I want you to also notice that there are 2 x's in the denominator. So we had said, using our quotient rule, that x to the third over x to the fifth is the same thing as x to the negative second. Now, we're going to talk about this in a later lesson, but whenever we have a negative exponent, we're going to want to rewrite it in its proper format, which we just talked about, which is x or 1 over x to the second power. They mean the same thing. We'll talk about why that is and how to utilize that in a later video, but just remember, whenever there is a smaller numerator than denominator, you're going to have some exponents left over in the denominator, okay? Let me know if you guys have any questions. I hope you guys have a fantastic evening. Bye-bye.